Hi guys, I'm Sam from Prohelion, here to talk to you today about CAN in the use of Prohelion products.
Hi.
And this is Cameron.
Hi, I'm Cameron Cheesley. I'm from Prohelion as well. Involved with this stuff day to day. I'm one of the main developers on the Profinity software suite. So we spend a lot of time dealing with CAN, talking CAN, trying to figure things that I can. Maybe it's worth just starting, before we talk too much about these, just going back to what CAN actually is.
Yep.
And how it's used in a system like the one that's in front of us at the moment. So.
Yeah, so CAN's a pretty mature communication technology. It gets used a lot in automotive because it's very noise immune and low power and just all around pretty robust.
Yep.
In the system that we've got sitting in front of us here, it's being used to talk between our battery, this driver control board that we've got here, and the motor controller as well.
Fantastic. Speaking of automotive, if you can hear some background noise, it's because there's actually a car being built behind us at the moment. It's using CAN bus technology to run, so it's probably timely that we go through this, because in not too long a time, a lot of this stuff's actually going to go next door and it's going to be put into that vehicle to make it work. So if you're using the Profinity technology, you're probably connecting to the systems which we built, which are all run on CAN, using one of two adapters. We've got this one here, which is a CAN to Ethernet based adapter, so Ethernet and CAN.
Yep. And
then this one here, which is the Peak. These are very popular product more broadly, which we support, which is the Peak CAN to USB adapters. Now, both of these have a option to dock this little CAN board on the back, which you'll get when you buy the CAN adapters from us. So it just simply goes in, usual 9-pin DIN. And the back here, we've got two CAN plugs and a power plug, and this is fused just to prevent it. Now, these two CAN plugs, if there's one issue, if you're new to CAN, welcome to the wonderful world of CAN. It's great once you get into it. But if there's one thing that causes a lot of issues with this, it's these two plugs and this idea of termination, and you know, so why don't we spend a minute just talking about termination and what that's all about.
So in a CAN bus, it operates as a differential signal, and also runs with a characteristic impedance of 120 ohms on the cable. So it expects on either end of the cable for there to be a 120 ohm resistor placed.
And it's that resistor is what we call a CAN terminator, and it's really, really quite important. So the number one common issue that we find with people that haven't used CAN before, so I'll grab a CAN cable like this one, plug it in, and what they don't have is the other bit that Sam's got right here, which is a CAN terminator. It's simply a 120 ohm resistor that's terminating that CAN. Now, if there's not a CAN resistor in the circuit closing this loop, you're just not going to see CAN traffic. We would generally recommend you put one at a couple of different places in the network.
And depending on the CAN transceivers that are being used in the network, they can generally drive up to about 5 terminators per network. But you probably want to stick around 5 and just pepper them where needed.
But you definitely need at least one. Even on a really simple network, if I was just to plug this straight into the Wave Sculptor, I would probably terminate this at both ends, but you'd need to at least terminate it at one. If you're not getting CAN traffic, the first thing I'd be looking for is you know, have you got one of those terminators? CAN terminator. The other thing, just kind of obvious, but just to make you aware, these little boards have a 12-volt input, and you can plug 12 volt into them, and that will actually power the CAN network, the CAN adapter. It'll also power the devices that are on the CAN network. So if you're looking to run, so for example, we use them to stand up if we're testing this Wave Sculptor, I'd be injecting the 12 volts for the Wave Sculptor actually comes in through the CAN, and that's the correct and safe way to do it.
Same thing with our battery management unit as well. It is powered via the CAN bus as well.
So it comes in through here. Now, the other common issue we see with people that are dealing with CAN is CAN speeds. And so when CAN is running through the network, it can run at a number of different baud rates. We commonly use 500, but it can run at a number of rates other than that. And it's important that your devices that you're using here are actually set to the correct speed your network's set to, otherwise you're simply not going to see that traffic. So for both the peak adapter and for this CAN to Ethernet adapter, there are ways that you can set the speeds that these devices will run at. You can set both of them in Profinity. They're set slightly differently though. This one, CAN to Ethernet, it's set in the, well, they're both set in the firmware of the device, but you actually right mouse click on the adapter in Profinity and then select the CAN speed. This one here, it's done slightly differently. It's done in the properties for the adapter. So in Profinity on the bottom left-hand side, you can set the various properties for the CAN adapter, and you need to set that speed. Again, if you're not seeing any CAN traffic coming through, it's likely going to be one of those two scenarios. Either you don't have that CAN terminator, this little tiny thing plugged in, or you've got the speed set incorrectly. And yeah, off you go.
If you're still having problems, the next thing to probably check is the cables that you're using themselves. We see a lot of clients are making their own CAN cables, which, you know, that's fair enough for most applications. You don't know what length you're going to need, or you just can't buy it. So you end up making your own. And if you've got a bad crimp, or you know, you don't have the right tools or something, you can end up with a dodgy connection. So that's pretty easy to check using a multimeter. We on our website sell overmolded CAN cables, which Cam's showing off here.
One of these,
they're very nice, and we haven't had a problem with them yet. Very, very rugged. We currently sell them in a 1 meter length. Even if you didn't need a meter and you only needed half a meter, I would still recommend buying one of these and chopping one end off and then terminating it as you would another cable, because then at least you know that half of the cable is always going to be right.
As you might be getting a hint from Sam, CAN cables over the years have caused us a lot of grief.
Yes.
And the number of times we've chased an issue around for an hour and then discovered that one wire somewhere in here just fell out. And particularly in an automotive application, I mean, one of the reasons these are so rugged and they're molded at both ends is you've got to remember, with all of this sort of technology, it's getting bounced around. It's not sitting on a shelf somewhere. As soon as you put it in a car, it's getting absolutely bounced around, and it's important that things stay connected, and particularly CAN, because if you've got key components of your CAN network that drop out, like the battery or the driver control system, which we'll show you in a sec, the car's just going to stop. It will enter a safe state mode because it needs to see the communication. This is just a little interesting device we just wanted to show you. This is a custom built board, but this is actually the CAN controller for our vehicle. It's a racing controller, so it normally has paddles here that allow us to control and drive things like cruise control and you know, everything to do with controlling the vehicle. We can even do basic communications with this particular one. This is actually an evolution of an interesting product we have on the website, which is our driver control system. So you can buy this as a small box that you can plug your own switches and controls onto. But this one is actually from our open source version. So on the documentation site, if you go there, you'll be taken to we can go to an open source site on GitHub, and you can download both the circuitry and the source code for this particular solution. And it's a really great place to start if you wanted to build your own driver control. So this board physically is quite a different form factor to the one that you'll find on the website, but it's the same electronics, the same circuits. It's just got a few little tricks in it, like these levers, and it's a really good way to get started. There are other ways you can build driver controls. You know, we see a lot of people using the Motec solutions. Anything that can be driven by CAN, we've got people that are doing it with embedded Linux devices as well. But you know, if you wanted to do a purely embedded approach, that is a really nice way to get things going. And it's the only real component that you need to engage, you know, to build the whole car. It is available there for free if you wanted to try and build your own, or if you'd like to buy one that's pre-packaged, you can get them off our website. They come in a small black box with a connector that you basically connect to your pedals and your indicators and so on, and that'll get you going from there. Anything else you want to cover with CAN?
No, I think that about wraps it up.
One thing I will say, if you're having any problems, please reach out to us on our support site. You can lodge support calls there. There's also knowledge base articles. In fact, you'll find a number of the common issues that we're talking about here, like CAN terminators, are on the knowledge base site. So check that out. It's a great resource. And if you still stuck, reach out and we'll happy to help.
Yeah.
So, thanks again.
Thanks,
See ya.
guys.